Hello, I'm Alexander Van Tylingen, a chemistry tutor at ClassRx, an online one-to-one STEM-focused private tutoring company. I have a degree in chemistry, a master's in nanomaterials, and I'm currently working towards my PhD in computational chemistry. I have been a tutor and lab demonstrator for the past year and a half, and in this section I will show you how to solve acid-base problems at A-level chemistry specification.
On board. The first thing you need to know is that there are two definitions of acids and bases that they require you to know. First being the Bronsted-Lowry theory. This may be the one you're more familiar with coming from GCSE, that says anything that gives off a H plus ion in solution is an acid, and anything that takes one or accepts one is a base. The Lewis theory says that any molecule that takes a pair of electrons from another species is an acid, and anything that gives one up is a base. So firstly, we can instantly see any Bronsted-Lowry acid is also a Lewis acid, and any Bronsted-Lowry base is also a Lewis base, but not the other way round, because a Lewis acid could include something like this. And that would be looking to gain another pair of electrons, not to give out one of its hydrogens. It is important to always think about these things in equilibrium, as you'll largely have looked at strong acids at GCSE level. And what do I mean by equilibrium? I mean, if you have a molecule like water, when it's a liquid, it is constantly converting backwards and forwards between being this one molecule and being hydrogen ions with hydroxide ions. Yeah, so it's always splitting apart and rejoining. Typically anything, this is what we would call, this is the medium line for which acids and bases are defined. If it's more acidic than water, it's an acid. If it's more acidic, if it's less acidic, then it's a base. Clear some space here. So if we have, let's take an acid, relatively standard one, hydrochloric acid, we can expect that when we mix it with water, that the hydrogen will leave the chlorine and go onto the oxygen of water. So you'll have your chloride ion and a positively charged hydronium ion. This is a relatively a standard thing used in a lot of examples and quite easy to remember and see how it works.
Thank you for watching this video. If you have any questions, please visit www.classrx.com or drop us a line at hello@classrx.com mentioning my name, Alexander Van Tylingen, in the title.